Descriptive Statistic in Data Analysis of Social Science Research ऑर्गेनाइज्ड बाय इंडियन रिसर्च स्कॉलर एसोसिएशन के तरफ से आयोजित किया गया यह व्याख्यानमाला में आज के हमारे वक्ता है डॉक्टर घनश्याम साहू, सहायक प्राध्यापक के रूप में कार्यरत है, भवानीपुत्र कलहांडी यूनिवर्सिटी ओडिशा से है आप। और हमारे दूसरे जो वक्ता है डॉक्टर ज्योतिका शर्मा मैडम, आप सहायक प्राध्यापक सिक्किम यूनिवर्सिटी में कार्यरत है। आज व्याख्यानमाला के अवसर पर यह कार्यक्रम का प्रस्तावना सादर करने हेतु मैं हमारे मित्र विकास कुमार, संशोधक छात्र अमरकंटक यूनिवर्सिटी से है, उन्हें अनुरोध करता हूं कि आज के इस कार्यक्रम की प्रास्ताविक पेश करें। विकास कुमार सर।
Okay, thank you. So, Kuldeep ji, you can listen me. Kuldeep ji.
जी।
Okay. So, first of all, I would like to welcome the Indian Research Scholars Association team who have organized this beautiful lecture series that's very relevant and significant for research, not only for the social sciences research scholar, but humanities and others who belong from humanities and others field and others background. I would like to welcome the core of my heart, Dr. Ghanshyam Sahu sir. Sahu sir has accepted our invitation very easily, and I would like to welcome the convener of this lecture series, Kuldeep ji, who is a research scholar of Nagpur University, and I would like to welcome Manisha Yadu ji, who is a research scholar of Pandit Ravi Shankar Shukla Vishwavidyalaya, Raipur. I would like to welcome co-convener of this lecture series, Deepak Kashyap ji, and I would like to welcome all the research scholars of Indian Research Scholars Association and executive member of this Research Scholars Association. As we can see on the screen, Megha Kumar ji and other member who will be joined after some time. So on the behalf of Indian Research Scholar Association and on the behalf of me, I welcome to all the participants and all of you. So thank you so much.
धन्यवाद विकास जी। इसके उपरांत हमारे आज के वक्ता, दोनों वक्ताओं का परिचय करने हेतु मैं हमारे सहयोगी मनीषा जी यादव मैडम जी को अनुरोध करता हूं कि वे दोनों वक्ताओं का परिचय यहाँ पर प्रदान करें।
Please unmute yourself. Manisha ma'am, please unmute. Please unmute yourself.
Thank you, Kuldeep sir and Vikas sir. Very good evening, respected sir, respected Sahu sir and all participant. मैं मनीषा यदु अपने एवं इंडियन रिसर्च स्कॉलर एसोसिएशन की ओर से आपका हार्दिक स्वागत करती हूँ, अभिनंदन करती हूँ सर, साहू सर। कार्यक्रम व्याख्यानमाला के शुरुआत करने से पहले मैं आज के हमारे मुख्य वक्ता डॉक्टर घनश्याम साहू सर जी का परिचय आप सभी से करवाना चाहती हूँ। आदरणीय सर, आपका नाम डॉक्टर घनश्याम साहू है। आप सहायक प्राध्यापक है एजुकेशनल स्टडीज डिपार्टमेंट, कॉलेज ऑफ टीचर एजुकेशन भवानीपटना, कालाहांडी, उड़ीसा में। सर, इससे पूर्व भी आप 3 वर्ष राजेंद्र ऑटोनॉमस कॉलेज बालांगीर में अध्यापन कर चुके हैं। तथा एक रिसर्च ऑफिसर के पद पर आप अमिटी ग्लोबल स्कूल भुवनेश्वर में भी काम कर चुके हैं। सर, आपके द्वारा भारत सरकार के साइंस एंड टेक्नोलॉजी विभाग द्वारा प्रदत्त 2 इम्प्लीमेंटेशन कम एक्शन रिसर्च प्रोजेक्ट पर कार्य किया जा चुका है। सर, इसके अलावा भी आपके द्वारा 9 ऐसे मूल्यांकन परक प्रभावों का निर्धारण करने वाले रिसर्च प्रोजेक्ट पूरे किए जा चुके हैं तथा सर आपके द्वारा 9 रिसर्च पेपर नेशनल और इंटरनेशनल जर्नल में भी प्रकाशित किया जा चुका है। आदरणीय सर, आप उड़ीसा इकोनॉमिक एसोसिएशन और ऑल इंडिया एसोसिएशन फॉर एजुकेशनल रिसर्च के सदस्य भी हैं। इसके अलावा विभिन्न विषयों पर समय समय पर सर आपके द्वारा बहुत सारे ट्रेनिंग प्रोग्राम और वर्कशॉप में भी भाग लिया जा चुका है। सर, अगर आपकी शिक्षा के बारे में भी मैं सबको बता दूं तो सर आपने बीए ऑनर्स संबलपुर यूनिवर्सिटी से किया हुआ है। सर, आप 3 विषय में सर आपका स्नातकोत्तर पीजी है, एक है एजुकेशन और एक रूरल डेवलपमेंट और इंग्लिश लिटरेचर में। सर, आपने एमफिल संबलपुर विश्वविद्यालय से किया है एजुकेशन में और आप रूरल डेवलपमेंट विषय के अंतर्गत रूरल एजुकेशन टॉपिक पर आपका सर पीएचडी रहा है रवेशा यूनिवर्सिटी कटक उड़ीसा से। सर, एक बार मैं पुनः आज के इस व्याख्यान में आपका स्वागत करती हूँ। सर, आपका स्वागत है।
Thank you so much for your briefing, and thank you Vikas and other member who have invited me, and it is an honor for me to share my experience, not for only because what I have learned or it is theoretical based, but what I have experienced since last 1 decade, particularly as I was morely engaged in the research and development sector. So I hope I try to share my experience and make the session more interactive. Thank you.
विकास सर।
हाँ जी, yes
सर, मैम से आप लोग।
हाँ, I will send later, Manisha.
हाँ।
Hello, Ghanshyam sir.
Because shall we start or we need some?
Okay, sir. Okay, sir. No problem, sir.
Because shall we start?
Yes, sir.
Okay. Thank you, everyone, and I welcome all of you for this sharing session. I don't think it is a training session or something else, but it is sharing sessions. I try to share my experiences and how you can use the descriptive statistics. What are the major issues in using descriptive statistics, and how we can develop your skills so that it will be helpful for you to not only theoretical based, but also how you can use that in your research activities. So just with your permissions, I'm sharing my screen here.
Sure, sir. Sure.
Is it visible to everyone?
Yes, sir.
Yes, sir.
Am I audible?
Yes, sir. Yes, sir.
Okay. So as you know that now it is now research and development is one of the more focused area, and using the quantitative data and And morely, if we see in today's in statistical, or you can say that the research domain, most of you we use the various qualitative and quantitative techniques. But sometimes what happen without have some fundamental background related to how you can use those various statistical tools and techniques. Sometimes the students fail to implement that. Those they are very strong in the field of calculation, statistical tools and techniques, but they face difficulties in implementing or utilizing or applying those tools and techniques in research and in their research activities. So just have a brief background on that. The what exactly statistics is. At all of you are we are much aware that this is a branch of mathematics where we are more focusing on the structural method and primarily dealing with the collecting and analyzing the data so that we can describe or present the data in a more meaningful way. As you know that we are dealing with most of us, the social science researchers are dealing with the various sets of data and from the various sources. So if the data are not collected by applying or appropriate methods, so it is very difficult to categorize them and make them more bring in a very presentable forms. And also it is very difficult to analyze those data if the data are not properly organized. So the meaningful in layman point of view, or we can say that wherever we are analyzing, collecting and analyzing data to give a better representations to the data so that the readers can understand the data set very easily. So here the more important thing is that how you read, who your target group, your reader will going to use your research publications or maybe the research. So that is more important, how you are easily you are presenting your data. And we know that it is more focused on the relative results as from the traditional mathematics, which are very absolutes. But in statistics, we are taking the more relative results. We cannot say that this is exact number as it is morely acceptable in case of mathematics. So these two things you have to remember, that always you give a relatable or relative results whenever there is the outcome, the calculation outcome there, it will always give a relative results. So before we going to that the descriptive statistics, as we know that the various the scales or the data that you are using by appropriate tools or appropriate the scale. So broadly, as you know, there are four major type of scale, that is your nominal, ordinal, your ratio scale and interval scale. But whenever we are dealing with the descriptive statistics, we morely dealing with the various type of categorical data. One is the nominal data. As you know that these nominal data are the group data, or you can say that the qualitative data, which are on orderly data. And whatever the data that we are collecting, it is in classical, it is in categorical form, like say, for example, the male and female, gender is a variable, male and female you are taking. Then we are talking about any caste is a classification of your SC, STs and OBCs and other things, or primary is upper primary, or we can say that the secondary school. So these are broader nominal data, which are group data, and it is not orderly data. We cannot say that, say, for example, male and female, which is better and is fast and come fast and which will come second, like your other classification data. Primary, secondary, and the second upper primary, and these data also come under your orderly data, but this is a type of group data. But the orderly data morely taking about with the consider about the ranking and priorities. So in case of ranking and priority, we take an example of income, lower income group, middle income group, higher income group, or you can say the categorize the data into the student intelligence based on their academic performance. Say, for example, low achiever, middle achiever, higher achiever. Or in case of, say, for example, in your economics data, low income group, middle income group, and high income group. Apart from that, the binary data is also mostly we use in the descriptive statistics. That is true binary, either in yes and no form or maybe in the form of true and false form. Then we are dealing with apart from the categorical data, we also use the numerical data in case of descriptive statistics. So it is two types of data that normally we'll use. That is your discrete data or continuous data. In discrete data, what you'll do, say for example, it is absolute number, not the fraction number. Say for actual number of students in a class or number of traffic accidents in a particular period of time. Say for example, we are taking a decadal data of last 1 decade or 2 decades. So absolute number of the passenger or the people who have made accidents in a particular period of time, that type of data will be absolute data. But however, apart from the discrete data, we use the continuous data where the fraction is used. Like say for example, height, it maybe comes in 5.7 or 5.2 or whatever may be. And also age of the persons. If we are not considering age the absolute number, say for example, 5 years, 5.5, 5 year and 5 month, or 5 year or 7 months, whatever it may be. So continuous, or we can say the weight is one of the data, which is sometime also continuous and sometime also discrete. But it is the priority whenever you are collecting the data. That's why what we are saying, it is relative. The type of data that you are dealing, you should be very clear-cut about whether a particular data that I am dealing with, is it discrete data or maybe a continuous data. So that will decide what type of statistical appropriate tools that you'll use. In subsequently, when we'll take an examples, you'll able to understand how this data can be the same height and weight data, how it can be a continuous and discrete data. So like how do you collect the data in statistics? As you are just, I'm going through overview so that it will be make the presentations complete one. So when we take the data, considering the total population, then it is very difficult to reach each and every population, as you know, each and every unit of the population. So that's why we'll take a sample and we consider, most of us, as we are dealing with the descriptive statistic, we are using morely, we are dealing with the samples. Whatever the findings will be there, it will be the description, or we can say that the description of the sample. We cannot generalize the outcome or the result of the sample based on the population, as in case of the inferential statistics. So be sure that whatever the data that you are collecting or you are dealing with or analysis that you are doing, we are focusing on the sample rather than the populations. And it is very difficult to generalize whatever the result is there on the entire population. So this sample and population is more important whenever we are going through it. And second thing is that, as you know, that how we are picking up the data. So as all of us, we are aware that either we take a strata or we may take a random. So strata is very effective frame where you have there are, we can say, the heterogeneity of the data. Say for example, you are collecting a data from a particular districts where the diversity is very is more. Say for example, the low income, middle income, high income group, or there are very we can say that the heterogeneity is there, more heterogeneity is there. Due to mostly you'll find the heterogeneity data in case of the urban area. But somehow in, say for example, in a particular travel dominated blog or GP, or we can say that a particular area that is morely on the related to homogeneous data. But whenever you are talking about semi-urban and urban area, you'll find mostly heterogeneous is more there, because the peoples are coming from the various parts of that locality and they are staying. So in terms of the heterogeneity, you'll find in their language, in their food preference, in their economic and social background, in case of educational background. So that is the more important, that how you are picking up the data. And if without considering the heterogeneity, you will directly randomize the data. So there are maximum possibility that the data, some importance elements or importance sample may be skipped there. For example, we are conducting a study related to how a particular nutrient varieties in agriculture research, a particular nutrient variety is responding to various type of crop. So you are considering, you are randomly picking up those data. Say, for example, I'll take the maize, I'll take the millet, and I'll take the paddy. So all the millet, paddies, and this corn, all are the cereal crop. If I ignore the pulses and the oilseed varieties, so my the ultimate findings will be, I can draw the conclusion only related to the pulses, related to cereal, not on the pulses, not on the oil sheet. So you have to categorize your populations into 3 different sample frame or the sample strata. For example, your cereal is one of the strata, your pulses one of the strata, and also oil seed of one of the strata. Or maybe say, for example, the spices, your ginger, garlic, this type of things. So that strata is more important. And then you can go with the randomized sample. But sometimes what happen, when suppose one of the practical problem is that you forget that what you have collected, the data, whatever the sample that you have collected, you have not made the strata or the frame in the very beginning. So we'll go for the post stratifications. Understand? Even you have not made the strata where from the very beginning, you have to make the strata in the post stratification, because you have collected the data, and based on the and you'll find that there are some heterogeneity in the data or in your sample. So you have to reframe the sample and again make a post stratification based on the data that you have collected. You have to frame your sample in different groups. So there is that is also one of the major stratification. Either pre stratification you will take, or maybe you take the post stratification, and you will take the random sample. Then type of statistical tools that we are analysis that we are doing, either you will go the qualitative, as you know, or maybe the quantitative. In most of the quantitative data, you will find in the first cases based on the number or the measurement or the counting. In the first frame, you will find that these the glass tube have the exactly it swings the number or continuous form. It is, say, for example, 46.5 ml liquid in the tube or test tube. But at the same time also we are collecting the mass of a particular copper carbonate or whatever the material that you are using. It is also, say, for example, 20.5 or 21.23. This will tell you the quantitative values or quantitative representations of the elements. Like in the height and weight of the populations, it is in the quantitative form. But sometimes these same data can be utilized in the qualitative form. How? Whatever the data you have, whether the solutions or a particular that you are saying, it is what type of smell or what type of fragments it is coming. So you cannot define that particular fragments in the quantitative form. So you have to make it the qualitative form, where observations and we can say that the individual interpretation is more important. And also, say, for example, whatever the liquid you have, whether it has the hot, cold, or it may be in whatever it may be form. So that decides that how you are dealing with the descriptive data, a descriptive statistic. Because unless and until you have not have a thorough idea that what type of data to be treated in which way, it is very sometime what happen ki we'll put the data in a wrong way, in wrong classifications. So categorical and numerical data, broadly you can say that the category data has equal importance role while we are making data collections and the analysis to draw the conclusion, or to not exactly to generalize, but to come out for a absolute or relative results in that particular areas. So what exactly in 2 ways also you can have that descriptive statistics and the inferential statistics. In descriptive statistics, what you'll do, it involves the organizing and summarizing and displaying the data, like in the form of table, charts, and average and graphs. Whereas the inferential statistic that involves the sample of data and also draw conclusion about the population. So broadly, we are talking in descriptive statistic, we summarizing and we can say that the presenting the data in various useful manner, which can be easily understand by the reader. But you cannot generalize the conclusion, draw the conclusion on the entire populations. So this is the 2 ways of the data. Broadly, you will see the difference. So we can draw the conclusions of the population in inferential statistic, whereas we can summarize the data only, or we cannot draw the conclusion on the entire population. The object is draw conclusion based on the population data, whereas the sample characteristics, the characteristics of the sample and population is more on the descriptive area. And drawing the conclusions and estimation is an prediction. You can predict and you can estimate what will be in the future. In, say, for example, we take the trend data of the last 10 years of your student performance in class 10 exam, and you can to estimate that how the student performance and moving to in which directions, and you can predict also. At the same times, in estimations about the agricultural productions and early estimation, as you know that the budget estimations can be come through this inferential statistic, whereas in descriptive statistic we morely dealing with the summarizing and presenting and organizing data, and mostly probability scores and the statistical tools that normally use fairly higher order statistics, whereas the chart, graph and table mostly used in descriptive statistic. And you know the tools for the hypothesis testings, ANOVA and COVA, whatever the tools are available. But mostly we are dealing with the measure of central tendency and the dispersions. And the population, whenever we are taking the data, it is morely in the large population to draw the conclusions, to generalize the on the population, whereas in descriptive statistic we'll take the small sample. So this is broadly about the overviews that what are the basic the necessities to going to the descriptive statistics. So I have few questions. Let's have some ice breaking sessions. What exactly we are looking today. So how do you know that who is the better ODI batsman, Rohit and the Virat? Any view on the audience, the participants, to whom you consider as the best or the better ODI batsman in Rohit or Virat? Am I audible?
Virat.
Vikash?
Yes, sir. Virat. Sir, Virat.
Any other? So all are agree on the Virat. So
Yes,
what is
sir.
the basic of that? If you are considering the Rohit and comparing the two batsmen, Rohit and Virat, how do you know that the Virat is better ODI batsman? So that's why we can
Looking
consider
at the run rate, sir.
Yeah.
Run rate, sir.
Okay, so definitely we'll take the betting average, right? We can.
Yes, sir.
We should take the betting average of both, and then we can come to know that give our comment that yes, these batsman X and Y is better. Second is who is the more reliable, whether Dhoni and Yuvraj. Who is more reliable? How do you know that?
By the consistency, sir.
Yeah. So
Dhoni.
So you have to consider the score variance or the consistency, how consistently a particular player is doing. Say, for example, in one match, one is scoring 1, another is 50, another is 2, another is 8, another is 20. So in such cases, in one, another way, say, for example, one person is making 30, 50, 60, like that consistently. So your score variance is more is one of the criteria or the indicators through which you can say that whether Dhoni or the Yuvraj is more reliable. So another is a triangular series among the India, Australia, and England. Who will win? How do you know that? Any comment on that? See, it is only related to your descriptive statistics. So based on that, you can answer or you can respond.
Probability, sir, I guess then.
Probability. Achha. Any other view? You don't go into more.
Sir, we can.
Yes.
Sir, England, yes. Most of the time it's in England.
But what is the criteria? Who will win the series? Suppose three teams will fight together. Who will win? Don't go in very deep. Just it is related to whatever comes to your mind.
Sir, it's
Are
seen
simple.
England in
Most of
most
the
of the time
wins.
mode. Yes, mode.
Whoever will most of
Yes,
the
sir.
match that
England.
will win. Okay. So
Yes, sir.
then, if you are going to buy shoes, which brand has the has most varieties? Adidas or Reebok, say for example, will take. Which brand has the more variety? So in how do you know that? So broadly about the price range, say for example, what is the in terms of the price range, in terms of the variety they have maintained. So broadly, you can say that whenever you are coming to as a research scholar, you should be very cautious. Whenever it comes to your mind any question related to that, you should answer your response or your response very based on certain criteria. Okay, so whenever most of we will find in most of the now a tendency is that now suppose in a study you will find that we make a hypothesis that the performance of the boys is better than the girls. No doubt it is a based on the inferential statistics, but the null hypothesis that you are making is based on your descriptive statistics. If in literature reviews and some evidence which show the descriptive status of a particular, we can say the sample or the population, unless and until you are not clear about that, or if being a research scholar or being a researcher, you should be very cautious about framing your research hypothesis and other things going any alternative hypothesis based on your descriptive statistics. So you can say, for example, if we are considering in my last example, the performance of the last 10 years of boys and girls, and we found that the average mark or the percentage of the students, particularly of the girls, is securing better mark compared to the girls, or you can say that than the boy. So based on that, you can draw some conclusion or frame some hypothesis. Whether the difference is the statistically significant or not significant, that later on it will come. But thing is that unless and until you not have a basic the statistical basis, it will be very difficult to come to either to decides the inferential statistic. Being a research scholar, your work is not only limited to the descriptive statistics. Definitely, you have to go for the inferential statistics. So, inference to decide the inferential statistic, the best is your descriptive statistic. Status of a descriptive statistic or status of a data based on the descriptive statistic will decide whether what type of inferential statistic will follow or whether you are going in the right direction or not. So broadly, that today's session that we are looking about this type of activities. So we can say that descriptive statistics, it is a can say that it sets up tools and technique which is quantitatively describes this summarize the main feature of the database or your sample of the sample. So main features of your data will describes or summarize the main features of your database. Then second is how you are organizing, the analyzing and presenting the data so that it is easier for you to understand and interpret. And also it will be easier to grasp the content or understand the contents by the reader. So better way we can present the graph, chart and table in a various way. So main type of that we are talking about nowadays is measure descriptive statistic is your central tendency, the measure of dispersions and measure of shape or distribution, that you're talking about your probability distributions, or we can say that the probability distribution. So understanding the shape of the distributions of your data set and based on the distributions, how you can measure your central tendency and dispersion is more important. See, now the calculation and formula has very limited, you can say that the has very less use for being a research because these are ready-madely available, whether you'll go to the use any statistical application. But understanding and application of those statistical techniques and tools and techniques technique is more important than the calculation, because suppose we'll put the data, definitely will come out some conclusion. For example, if I'll calculate the correlation, and my correlation is, say for example, is talking about the snowfall in Kashmir and number of babies born in Uganda. Both will have some statistical, or you can say that some numbers will come. The snowfalls in Kashmir and number of baby born in Uganda. You will put the data in statistics and you will ask the SPSS and the R, or you can say the Stata, to calculate. So it will come out with this, say for example, the is coming about 0.87. Okay, so you'll say that you'll draw the conclusion that there is significant correlations between the snowfall in the Kashmir and number of babies born in Uganda. So somebody will see that data set and what will be interpretation, what will be his impression on that. So understanding the data set is more important. So calculations will definitely calculations. That's why the error will come definitely in data analysis process. So understanding this descriptive statistics is the best for the inferential statistics. So these are broadly in a descriptive statistic. We are dealing with the distribution series and its measure of central tendency and dispersions, or the variability that we call. As you know, just I'm giving a brief on that. The mean median mode is, as you know, the arithmetical mean, the total whatever the score that you are getting, and divide with the total number of sample. So it will come with the mean, and mostly we'll use the in social science research, it is morely interval or the measurement data, measurement scale, either interval scale or maybe ratio scale. But as we have very less use of the absolute data, or for example your ratio scale, we use mostly confined to your interval scale. So that is called also the measurement data. In median, you know that the 50% below the mean and above the mean, and mostly we also use in the ordinal and the measurement data, ordinal scale and interval scale. And mode is definitely we're talking about the mean, nominal, ordinal, and sometime measurement scale when we're talking about calculating the what do you call the post hoc analysis, or we can say that about your what we call the chi-square test in ordinal scale, or also the rank aspect data that we are talking about, the fragment. In your fragment test, also will converting the nominal data into measurement scale, and we'll go for the post hoc analysis. So this is, as you are aware that I'm not going in details on that. And as you know, see just an example. Suppose all the number are there and we'll divide by the total sample, it will come the mean. And in the median of the number, say for example, when it is an even number, definitely the median number, when it arranged from the in ascending order, the middle number will come, or the middle number, whatever the score will be there. Or whereas we can consider the when it is a in odd number, but when it is even number, definitely the midpoint will consider the remaining close number. But whatever the maximum frequency will come in a particular data set, will consider as the mode. Whereas the common measurement for the variability is the range, variance, and the standard deviation. Those, the average deviation and quartile deviation are coming, but mostly you will use in the social science research in range, variance, and the standard deviation. As you know that the range is simple between your largest number and the smallest number. You will taking the data series, whatever the large number and small number will come, will take on that the range. Whereas the variability is talking about the variance is, say for example, this is the mean value, how the mean is difference from the particular the data point is differ from, or variance, how much it differ from your mean data. So based on the variance, then also the square root of the root of the variance will come out with the standard deviation. Now mostly we'll use the standard deviations and invariance and mean in case of standard deviation will consider. That is one of the important area. Okay, so just for that, just I'll go through a videos related to that. If with your see, suppose
धन्यवाद साहू सर। विकास जी, कार्यक्रम के अगले चरण में पढ़े।
अभी साहू सर will be speak something.
It is visible now?
Yes, sir.
It is coming? It is coming?
Yes, sir.
Suppose you have the 5 variable here. Say, if I'll take the 5 variable, your name, the gender, am I audible to everyone?
Yes, sir.
Hello?
Yes, sir.
Yes, sir. Voice is clearly audible.
Sir, your voice is
Am I
clear.
audible?
And yes, sir, yes, sir. Your voice is clear, and sir, your video is also clear, sir.
Hello? Because I'm audible?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay, sorry. See, I have taken, say, for example, these various 5 variable I have taken. Okay.
Yes,
And I
sir.
have, say, for example, 4 observations. In what you will do, say, for example, in descriptive statistic, what will do, say, we have the various variable that we will take. Say, for example, the name, gender, age, weight, and height. So, and we take, say, for example, 4 observation. 4 observation means we have taken the 4 uh, the sample that we have taken, say, for example. Then, in such cases, as we have discussed earlier, can you identify which are the categorical, we can say the numerical value? Hello? Which
Yes,
are
sir.
the categorical value?
Age,
And
Name,
age,
gender,
weight, height,
name, gender, age.
is, hello? It is, which are the variable, which are categorical variable.
Sir, gender, age, and name.
Sir, gender.
Gender,
Only
age.
gender.
Age is a
Gender
categorical variable.
No. Sir, gender is categorical variable.
See, that's why I told you, unless and until you will not see the data, it is very difficult. Say, for example, age will come, it is middle age, or we can say that the elder, or we can say the young age, and old age will come. So it will become?
Categorical.
Yes. If it is coming, say, for example, in absolute number, say, for example, 25, 38, and 39, then it will become? Numerical. So, say, for example, suppose you have the 5 variable and you have the 4 observations. So, based on that, how it will come? We can understand that these 4 variable, say, for example, you take, it is a James, a person's who is and is male. Based on the, you will consider these 4 major characteristics, the 5 major, we can say, the variable name is, say, for example, James, then his gender become male. His age is 27 years age, and he is, for example, the height is short, for example. So the height become categorical variable. Whereas you will consider his weight is 75.1 kg, it will become numerical. Which type of numerical data? Which type of numerical data? Already, that's why I've given a background on that. It will be a which type of numerical data? Discrete or continuous?
Continuous.
Discrete. No, sir, discrete, sir.
How it will become discrete?
So it's just a number. It is not having any kind of range.
What is the discrete data? Discrete absolute number. It is not a fragmented data. Fraction of data is not there.
Yes, decimal point is there.
So how it becomes continuous? It is a continuous data. Okay. So whenever there is absolute number, suppose it, say, for example, 25 kg, it will be a Which type of
Discrete
data?
data. Discrete data.
Yeah, discrete data. And say, for example, age become 27.5, 27.5 year, it will become a continuous data. So that type of data, whatever, that's why I'm saying, if whenever we are collecting the data, you should fix that whether I'll collect the discrete data or whether I'll collect your continuous data. So from the very beginning, that's why it is procedure for the collecting the data. If your questionnaire or your tools will not properly mention about that, suppose you have collected the data, somebody will find it will be 27 years, somebody will take, no, sir, it will 70 or 27.5 years. So suppose I'm giving an example. In one of our research, we are collecting the data. What are the collections of the people of a particular tribal dominant area, the collection of the Kenduli. So we have not fixed the data value. The unit value we have not fixed there. So what are the data is coming? First thing is that 5 bundles. Another is saying that we are taking the 2 head loads of the bucket, basket of the kenduli. Some sample they are saying that no, it is in 5 kgs. So, sorry, in quintals. Somebody is saying that it is the 10 bags. So in such cases, it will be very difficult for the researcher to which unit value they will take. Suppose you have not fixed the data from the very beginning, and you have collected data and you will got the data later on. Then how you can draw the conclusion? How will categorize that? So from the very beginning, you should very clear about whether your data is qualitative and quantitative one. Like say, for example, in case of the height, always you consider it is a quantitative data. Suppose I'll put the data in this solve that what is your height, sickle and height, very short. Okay. So you will ask the data and you are collecting the family profile and you will ask how many brother and how many, you can say that the children do you have? They will say, for example, 5. What is their heights? They will just ask, say that one child is available. He will say that this is my middle son and daughter. And one is he just taller to him and another he is just shorter to him. So in such cases, you'll get confused whether the child has taller or the shorter or which type of what measurement they will put. So in such cases, it will be very difficult. So you should be very careful about your data. Say, for example, you put these 4 things. If I'll put these 4 things in one categorical data. So name is one of the...
Sir,
Yes?
excuse me.
Yeah.
But while at the stage of designing tabulation itself, reference, date, and unit is a must, no, sir? Unit.
Yeah, definitely. That's why I'm saying the collection, what will we consider the descriptive statistic only after the data collection is processing is the more important. But you are not very precisely mention your unit value from the very beginning in your tools. So you should very precisely mention what unit value that you are going to collect. Mostly in social science research, as we are dealing with the human and the diversities of the perception of the people and response of the people varies from region to regions and from the person to person. So unless and until you will not have a precise unit values and type of data that you are dealing with, whether it is a quantitative and qualitative data, if it is quantitative data, which scales that you are using, and it is even in scale also, whether it is discrete series or continuous series, you have to very mention from very beginning, as you have rightly pointed out. So it is more important from the very beginning. You should be very clear about that. Okay. Am I clear to you?
Yes, sir.
So you should have a very precise idea on that. So this, for example, the 5 you are collecting the data from the James, the name, and your mail, and accordingly you have to fill up the 4 data, 4 respondents, for example, 4 data that you have collected the data from the 4 sample. So these are, you can say that your gender and height. Now name we not consider the name as one of the criteria here, because say, for example, the basic data, but primarily 5 variable you will consider also, that the gender and your height become your categorical, it become your numerical data. So you have the 2 sorts of data. Another thing is that in gender and height, what are the difference? Can you identify? In gender and height, both are the new.
Sir, in gender, there is two categorical variable. One is male and female. What is height? There is three categorical variable. That is short, medium, tall.
No. What is that? What referred to that? What referred to that?
Sir, sub-categorical variable of height.
Both are the subcategory variables. But in
Sir?
In gender and height, gender is here is a nominal scale. Okay, correct?
Yes, sir.
And height is what type of scale?
Ordinal.
Yes. So here we have taken gender is a, both we have taken the categorical data, but gender is a nominal data and height is a ordinal data. Second, we have taken age and weight is two numerical data. One is your continuous data, another is your discrete data. Correct? So the your type of data and your data presentations and the descriptive statistic will decides the which type of data that you are putting. So here we will say you will consider the gender. If we categorize these two data, we can consider the male and female is two. So if we consider we'll take age in another way and in two ways. Say for example, we'll take the one categorical data, another is your numerical data, and we'll categorize these two data. Male, say for example, you have the 27, 32 and 23, and the female is your 34. But in categorical data, the male become 3 and your female become 1. Okay, so in such cases, you can categorize based on that the gender and your age become your two important variables that needs to be deal with appropriate statistical tools and your thing. Secondly, whenever we are talking about the height, we consider the threes. Say for example, take the name. So 3 name we are coming. We mostly what we will do, say whenever we are considering the ordinal scale, you should from very beginning you'll find that most of the what you'll do data short, medium and tall. But in arranging what you'll do, say for example, medium will come fast on the tall. Whatever the statistical data will come, it will put in that way in SPSS and Excel. They don't consider the short, medium and tall in always. Suppose I'll put the data, it is based on the ABC alphabetical order mostly will come. It will instruct only, it will arrange your value, arrange your data based on the values and the frequency. Then it will tell about maybe tall, medium or the low. But whenever we are considering the orderly data, be considered that it should be in ascending order or must be in descending order. So it will put that in orderly way. Say for example, put your these two categorical data, height in short, medium and tall, and category you will consider the age are the factor. Age is one of the categorical data, in your numerical data, and another is your weight is your data. But what is the difference in that? Here you'll find the absolute number, your 32 and 34, whatever will come, for example. And accordingly, you have to identify which are the data point. See, I am putting this in where I am taking these examples and I will convert all those examples in the probability distributions. See, what happened in most of the times, what you will do, we only consider whatever data that you have collected, but you don't know how the distribution has been formed, how the mean has been come. Say, for example, you have your standard distribution deviation will come the 5 and mean is, say, for example, 32. But this, you should be very careful. You should be very sure that how my data structure has been distributed in the normal distribution, so that whenever you are applying for the inferential statistic, it will be very sure that it will be very easier for you to understand that how I have framed the questions and come to a conclusion, so that your fundamental will be very clear from the very beginning. So here in ACE, we'll have the two, say for example, data, but here in weight, you'll find that 98.3. So it is a continuous data. So this continuous data is range from the 98 to in between from 98 to 99. So your treatment from the both numerical data and continuous data should not be same. Okay, so numerical variable will consider how this can be from. Suppose here you have the various name. Say for example, you have 10 or 20 names and you have the age. So it is important to distribute. What you'll do directly will go and we make what you'll do will make the range or class interval from the 5, say for example 23 to 23, say for example 20 to 25, 26 to 30, will make that. But it is important to understand how my data distribution has been there in a particularly distribution manner or in a probability distribution. So I will make, say for example, 25 is there, one data is there, 26, one data is there, and in 23 you have the we can say the frequency or 3 persons, and you have the 6 persons in your 28 and 29. Accordingly, you have to distribute your data. See, these are not, you can manually it is very difficult, but whenever we are making a histogram in your statistic, in your using SPSS on Excel, it will be easier for you to understand that how my data has been framed. So, and this will help you to whether my graph is in appropriate manner or not, whether my data is in appropriate distributions or not. So you'll find, see, you will see that there are two, most of the data that you'll find. If you have, if you remember, or if I'm not wrong, there are some in 2018 or 19, there was a survey in your National Health and Family Survey, and you'll find the options are like that, 8 options, and 3 options are talking about the adolescence girl from the 16 to 24, but there is option also was there possibility of 10, 20, 10, 12, and 13. But you are targeting the adolescence girls. But they are probably very beginning they have framed that the data to be collected from the 16 to 24. So in such cases, what will happen? It will come the 10, 12, and 13 will come the 0, 0, 0. So, but still you are referring in the data. So these data, say for example, in such cases, you have frame a range, say for example, 24 to 30 or 32, but you have another options in your questionnaire, 33 and 34 and 35, and you will come 0, 0, 0. You'll find the most of the students also, what if it is 0, they are showing in your distribution table that these are the 0, 0, 0. And they'll, in the analysis version, they will find that there was no, we can say that, no respondent in the age group of, in the age of 33, 34, and 35. So in such cases, if that data is not applied to your research, and this outlier has some significant, you can say, is not contributing to your research, so this graphical presentation will help you that whether my distributions or data that I have collected has within the range, or I have collected the data which are not relevant to that. So in such cases, you may find some outlier and that needs to be dropped in your research study. So in such cases, it will help you, the numerical variable will help you to understand in accordingly how you can frame the data. So in numerical variables, suppose we'll take the max and in descriptive statistics, if for example, we'll take the minimum is the 4 and maximum is, if for example, 54. So we'll take that and range will become, what will be the range? Accordingly, the range will become, or interquartile range, it will become 50, or you can say that the 52 become your 4. So range will become 4. If we consider the interquartile range, see, interquartile range that refers to your the middle 2 quartile, or the middle persons, as you know that when your mean, median, and mode is lying together in one single point, normally or somehow in very relative points, so we consider this is a point related to your normally distribution. Suppose I take these interquartile deviations, I'll take, say for example, the interquartile range, suppose you have given the 20. So the middle, these range, say for example, this 10, 20, 30, and 40, and is become your 10 interval each. So middle 2 interval, say that these 2 interquartile range, it become your 20. So your data, the 20 is the referring these values, these from the quartile 1 to quartile 2 and also quartile 3 is the interquartile range become 20. And if we see the in same date, say for example, your mean become 30. Okay, So that refers to your pink color. Sorry, become to your which color? With your blue color. Okay. And your mode becomes, say, for example, is 29, which is referring to your pink color, and also the green become 20 and your median. Okay. So you'll find mode will definitely in the middle, and in particularly the mean will be if it is a probability or normal distribution, so your mean will come in the after the median, okay, and mode of the median. Suppose the data you will find that sometime it is not possible when the mean become that 30 and median become 28 and your mode become 29. Sometime the data is in go in the reverse direction. Reverse direction means that you might have some related to your what do you call the skewed data. You'll find sometime the skewed data. So in such cases, when the maximum outlier will be there, when the more variations is there, your mean comes to the left directions. So it is negatively skewed, and you'll find the median, the mean comes to the left of the your median. Okay. So in such cases, it's a left. In such cases, left skewed data, it will be very difficult to because the thing is that when you have such type of data, you have to take the accordingly the statistical tools device accordingly. If it is a rightly skewed or positively it is negatively skewed, so definitely direction will change. Okay, so direction will change, it will come, and your which was there in the middle between mean and median and mode become out. That means it will be come to the left direction. So in such cases, you have to understand whether my data is in left direct in rightly skewed or the leftly skewed or positively skewed or you can say the negatively skewed. So in such cases, when you have the more outlier, either the negative or the positive, you have to take a standardization process. We'll take the when you have that type of data, standardization process will take, and accordingly you have to treat your data accordingly. And apart from that, you'll find there are some you say the skewness and kurtosis. Kurtosis rarely used because when you have the long peak, you'll find the long peak, or we can say the short peak, that is not covered in these videos. So short and long peak, it will be very difficult because in such cases your thickness will decides and the shortness of the decides the your what do you call the type of normal type of your data distributions. So that will be accordingly the data point needs to be prepared accordingly. Like that, say for example, you have the positively skewed or the negatively skewed, or then accordingly you will take the say for example SD is 5. See, the calculation process of the range, interquartile, mean, medians, and mode, I am not going in details because you all are aware about that. But thing is that the major problem, whatever major problem that we are facing today is how can apply this data into the statistical, the social science research. Say, for example, your 5, your the SD and mean become your 5. So definitely you'll find the middle 68%, or you can say 34% and 35%. That means whatever the data that you are getting, say for example, your N is say for example 100. So you'll find that the 68 data or 68 sample in between 1 and 2 standard deviation. You'll find, say for example, if it is the standard deviation is very small or very large, say for example, or outlier, it will coming beyond that. So you'll find more of the outlier. In the middle, you'll find very limited data. You'll find the outlier will be more data. So in such cases, whenever your maximum data will not represent your values, so in such cases, your outcomes will be the ultimate decisions. We can say that the ultimate decision or applying an appropriate inferential statistics will be very difficult. And if it is more than going to the 20, say for example, 2 standard deviation will consider. So definitely, accordingly, it will be go beyond to 95%, up to 95%. So, and also this 95%, the data that we are talking today is in whether we are talking about 95% means suppose if it is middle, so 5% error we are considering. So at least we believe that the maximum data will be will be within that range. And if it is, you are saying considering the outcome of your research will decide whether it will start with a null hypothesis or a alternative hypothesis. Some always we cannot put the null hypothesis as no doubt we can validate or we can test the null hypothesis, but when we are not sure that, say for example, whether boys and performance is the better than the girls, whether the performance of the middle income group has the honest behavior than the upper income group or the middle income group. So where is your data point where you are getting this information? So the descriptive statistic earlier study, if that is there or secondary data is available, then you can also come that we can put your alternative hypothesis. Say for example, the performance of the better boys is better than the girls, boys then greater than the girls or better than the girls. So that data point will decide whether you will going in that direction. Okay, so most important thing is that how you can visualize those informations. If you understand the data, the most important thing is that how you present those data in your various type of forms. Okay, so these forms will decide you that which type of informations that I need to be put up in my data point, so that these data representations and my tabulation will be more accurate. See, you will put the mean, medium range. Say for example, male become 35, the female is 29, and total, say for example, is a mean. It will take the pool mean, say for example, 36.5. So this will only, and what will do, only will give a reference below that. The mean become 20 and mean the mean of the boy and become this, and the girls become this. Or sometime we consider if it is the variability is say for example very large, so we go for the suggest for the other statistical tools. If it is two or variable that you are considering, go for the t-test, and if it is more than that, then you go for your ANOVA test also. So, and also apart from that, if it is sample size also decides. If it is less than 30, definitely T will go, and more than 30 will go for the Z test. Okay, so that will decides that how the data point that you are considering is more important nowadays. So the maximum, minimum, or the range, or the whether SD is now considered is the one important direction for that. You will consider the numerical variable. Okay, the numerical variable, say for example, the 4 quartile you have considered, each quartile you can consider, and you will consider the interquartile coordinations that we are talking about. Suppose you have 4 what is there, and accordingly you will most of the data that you are putting here, converting in the graphs, and you see the first data that we are talking about, first data point that you are talking about, the representations with histogram is the most appropriate variable for that. Okay, so in such cases, you use a histogram based on that. And see, whenever we are selecting the data representation method in your thesis or in your data presentations, thesis, or we can say that any research thing, selection of appropriate graph is more important. Okay, so whether when we have a one numerical variable, we are considering one numerical variable with respect to the range, we normally use for the histogram we'll consider. Okay, suppose you have the numerical variable that deals with multiple types of data. Okay, say we have the 4 quarter, and we'll consider the interquartile range. So this interquartile, whenever consider, we go for the box plot. Okay, in box plot, you will consider the first is your first quartile, then second is the second quartile, and become the third is third quartile, and middle represent your median that we'll consider. Say for example, data has been spread from the 10 to 50. Okay, so you should go for the box plot. So interquartile range, that is the middle 50% data it will represent, and the median, the middle percent refer to the median. Whereas in beyond the data, whenever we are considering the interquartile range, we'll take 1.5 into interquartile range, and if box plot will show that if any data go beyond that, say for example here 2 data points are there, so these data points are considered your outlier, because this data has very significantly influence or may have the very negative influence on that. You will consider the categorical data in that way, and we'll consider this height is one of the categorical data. Okay, you will consider the categorical data in the frequency table. We'll see the short, medium, and the tall. We'll take the 4 or the ordinal data. Okay, and your frequency will become, say for example, 4 persons are there in the short, and your medium 2 are there, and tall is 2 are there. So you have the total, say for 8. So relative frequency, what you'll do, we'll take the 4 at the short form, and will take, say for example, 8. So relative frequency will definitely, say for example, 4 become your fast, and it will become the 0.5. So accordingly, you have to calculate that 0.5 to 0.5. Then how it will percentage? Simple, multiply with the 100. So it will become your percent. It will convert to your percentage. So frequency table, when we have the multiple ordinal scale also, we can take accordingly. And bar chart is an appropriate forms where it will represents your short, medium, and the tall. See, whenever we are presenting the data, be sure that from the very beginning, as I told, it should be either order in ascending order or the descending order. So if medium, I'll put first, and tall will put second, and short will put third. So it maybe you may write down, and in analysis form you may write down, but whenever the reader will see, he has to be refer the graph and also to refer to the text. If you have present your bar graph, and also the what you call the reader is again going to the text, so putting the bar graph has no meaning. So whenever you are putting the frequency table, you be sure that it should be arranged either in ascending order or maybe the descending order. Okay, so that will give you an ideas, or maybe you go for the pie chart. When you have that type of options, you should go for the pie chart. So that you'll decide how you'll measure that. Suppose you have the 2 categorical variable. Okay, one is your ordinal scale, another is the nominal scale. 2-way frequency table whenever you are framing. Say for example, one way you can take the short, medium, and tall, and like the male and female. In such cases, we'll take the calculate your percentage. Percentage, say for example, male will take the 100% and female 100%. See, in such cases, short, we know that the 50% represents earlier. See, last graph that we have made has linkage with the subsequent. See, what we make mistakes? We make a graphs in the very beginning, and secondly, whenever we are shifting to the second variable, what we will do? We change the data set, or we have the second data set, or the second graph has no resemblance with the first one. In such cases, your readers will get confused whether any examiners, whenever it will comes to the examination of your thesis. So definitely what technicalities that you have followed in your thesis or in your research paper is more important. So in such cases, what I'll do, in total column, you'll find I have used that, say for example, short, medium, and tall. I have not changed that. The total, based on that, I have calculated. And say for example, what you'll do, what in short, most of the cases, what you'll do, this short 100%, these students will do these are the is as a 100%. Most of the time you'll find. And so in such cases, there will be confusion. I should be very clear that what data treatment that I have taken in my earlier data point. And accordingly, you have to calculate your, whenever you have 2-way table, or you can say that the cross table, you should be very clear that what was my first, if I have considered one variable in earlier, whether my second category, the 2-way treatment, has the any resemblance with the first one. So accordingly, you have to prepare your data table or maybe your graph table. So in such cases, what will happen? Whenever we are coming to the bar chart, your male and female, and considering your these things as a major area, so it should be considered accordingly. This is not running. Okay, so male is 100%, female is accordingly 100%. So in such cases, you'll find the graph, bar graph will make accordingly. Okay, so in one we'll find either absolute number, you'll find either male, female. Each sections, or you can say that each tower will refer to the absolute number. Okay, it will refer to the absolute number. So it will refer here, as we have the two categorical variable. So is in one tower, it will refer you two type of. Say for example, male will refer also this short, medium, and tall, and also female short, medium, tall. But and sometime also will consider the percentage. So it should be very clear. If you have mentioned in a table, only either you have to mention a number, then you have to put your percentage. If you are putting the percentage in table, then give the absolute number. And you have used both short, you can say that the two-way categorical table, it is not necessary to present any type of graph. Okay. So when you have used, say for example, 10, if I have take the 3, 1 and 4, and 1, 2 and 2, 1, 2 and 2, and 5, 3 and 8. So this graph will be more appropriate in my thesis or in my research paper. If I have taken the percentage here, then it will be more appropriate, so that this they will get an idea. Then if the reader require the additional information, they may go to the table. And if we have mentioned both the percentage and your frequency, not necessary, it is not necessary to provide both the graph or either graph. If you have mentioned both things in one graph, you need not to make your paper more clumsy, because we are putting the same data in two different way, which is not necessary. So either you have to put one, say for example, one graph with the one either frequency or maybe in absolute number, or in absolute number in table, or frequency in the your graph. Okay, so that will decide that the type of data that what you are presenting. Suppose you have take the two numerical variable. Here you in one way you have taken one variable, and another is another age in your weight. Say for example, I have the two data point. Okay, so 34 and the 63.5. In one way, age is your C. Remember, whenever we are taking the two numerical data, and one is your discrete series and another continuous series, be sure that your x-axis should be the discrete data. It should not be the continuous data. Okay, so in any type of data that you are collecting, you'll put, say for example, the x point, and accordingly you'll put the all point together. Okay, whenever we are making the scatter plot, in scatter plot we have the two, say for example, either you may go with the age data or maybe both age and weight data. And if the both data is in absolute number, so it is not necessary to have that variance. But remember, because why it is there, because age is an independent variable and weight is a dependent variable. Okay, so these age and weight is dependent variable. See, weight cannot depends, the age cannot depends on the weight, but weight can be depends upon the age. So whenever you are putting the scatter plot, be sure that if we are putting that data either in continuous series, it should be in y-axis, and it is absolute series or discrete series, it is definitely in x-axis. Or independent variable is there, definitely you should come in your x-axis, and dependent variable definitely you should put in your y-axis. So that needs to be very clear, that if I have that type of data, how we can put the data in different ways, so that it will be easier for the reader whenever I am repeating the same things again and again, because reader is more important than whatever study that you have made. Because in suppose you have published a paper in related to the policy implications and program implementations, you have understood that the research has to be that it should add value to the program implementations, how the policies can be influenced, how the program intervention can be influenced through the research. Otherwise, if this program intervention and policy intervention has not been appropriately addressed by doing your research outcome, so doing the research has the no sense for that. So in such cases, we'll use that in age and the weight, as we have taken the two different variable, we should use the scatter plot. Say for example, two numerical variable and one categorical variable will take. We have taken the age and weight is two numerical variable. One is the discrete series, another continuous series, and we have only take the numerical series. Sorry, in the categorical series, that is the nominal scale. So in such cases, say for example, how we'll put that data. Okay, so we have the put the data in two ways as age is appropriate, and we have plot the is in a two different color, male as the different color and the female as the different color as per the data representations. Okay, then this will give you fair ideas This will give a fair idea how this age and weight has been putting together for the male and female. It will be easier for you to draw a scatter plot of age and weight by the gender. Okay, you will change this data point into two different ways, two categorical and one numeric. Say, for example, we'll take the two categorical. In two categorical, what you are doing? In two categorical, one is your ordinal scale, another is a nominal scale. And we have considered, say, for example, weight is a one variable. So here you can say the box plot that is one of the appropriate tools for that. What will refer? The box plot, the middle person's, the middle line represents your median, and the second and the left line and the right line of the median is referred to interquartile range, or you can say the 50% below that and 50%, 25% above and 25% below that. And your line, straight line, the standing line refers to these two. These are the standing line refer to the median, and this is your first quartile and this is your second quartile. And entire will refer to your interquartile range. And the data that you have refer here, these the straight line that you have refer, slipping line, or we can say the slipping line or the horizontal lines, this will be your range of your data, as it is a continuous series. Okay, so in such cases, we'll take accordingly. Suppose you put the two, male and female, together. So definitely it will compare you how the median of the male and female is differ, and what is their interquartile range, and how the data has been spreaded. So it will be, though you are presenting the data in your tabular form, but box plot of the weight will help you for the compare the male and female in particular. Like that, say for example, you have taken the student mark of boys and girls. So in such cases, it will give an idea that how you can compare. Suppose you will put the height and will put the ordinal scale together. So here we have taken the gender as a one plot. So it will be easier for you. But in certain cases, what will happen? You have to also compare to different dimension. Say for example, your tall, medium, and short. You will put the three different categorical data. Categorical data, but in ordinal scale, not in the nominal scale. So we'll put three dimensions. Say for example, two categorical data you are showing in the x-axis. You are showing the weight you are considering, and you are showing the which data. We can showing your categorical data. See, in last I have told you, when you have the two numerical data, then definitely you consider dependent variable in the x-axis and independent variable in your y-axis. But when you have the particular one numerical data, whether it is your discrete or the continuous, and you are dealing with the two categorical data, definitely you should have the y-axis in your the categorical data in your y-axis, because box plot always, it is not necessary it should be only in horizontal. It may be also vertical. The box plot may be also a vertical. So, but that will decides that when your data plot will be changed, when you are putting the tall line, or you can say the y-axis, you are putting in the, you'll find the two type of the two-dimensional graph is available both in Excel and SPSS. It will help you whether you are putting in horizontal presentation you are giving, or you are putting in your what do you call the vertical dimension that you are putting. That will tell you that how you can easily compare the tall aspect in one time, and medium the boys and girls in another second time, and also the short heighted boys and girls in the similar way. So these types of data will help you. The representation will help you while how you are making your data plot is more appropriate, and accordingly it will help you that how I'll put my data in a more appropriate way, so that the readers will get a very clear-cut idea. See, the calculations of your mean, median, mode, the interquartile range has very less significant unless and has very less significant if it has not presented in an appropriate way. So collection of the data and categorization of data and presentations, appropriate representation of the data with appropriate graph and chart, along with the facts and figure, is the core of your descriptive statistics, because this type of statistics will help you to present. Say, for example, your principals or your university will tell you, just give me the entire summary of your thesis in the 2 or 3 pages. So in such cases, it will be very difficult for you to precisely present your data in what you call the in text form. So in such cases, you will go through the, have you gone through the NAS survey, National Academic Achievement Survey report? You'll find in such cases only graphical representation they will follow, so that even you will not write anything. Your facts and figures along with the graphical representation will help you how you can represent the data. That's why now they are saying that the 1 pixels tell 100 and 1,000 words. So the major importance of your descriptive statistic is the graphical representations, and how you are treating the data in 2 different ways. How you are treating the nominal data and your ordinal data, even it is the both are categorical data, and how it combines the ordinal data with a numerical data which is continuous and discrete, or maybe your ordinal data with the discrete and continuous series is important. And important thing is that how we can put that data with an appropriate data representation methods. So this is just considering that whatever the time allotted to me, based on that I have tried to make it match as precise as possible. But I have earlier planned for at least I'll present 2 case studies with the actual data, so that it will be easier for you to also process how we can use the Excel and SPSS for the quick review. But considering the time slot available, definitely I hope that it will be helpful for you, to all of you. And this is all about from my end. Thank you.
धन्यवाद सर.
Kuldeep sir, any participant want to something to Sahu sir? So.
Have any doubt regarding that, or you have any comment on that how it can be more even add value to that? Okay, so participants are request all of you, you have any queries or any suggestions, you are most welcome for that. See, and also the video that you have collected is George Matthew. Hello. So George Martin is one of the renowned statistical application, particularly in the health science. Okay, so they have morely dealing with that how data can be and visualizations can be more appropriate. So the books of the George Martin, and also it is easily available in the YouTube channel also in his. So accordingly you can refer that George Martin YouTube channel. Accordingly it will be easier for you.
Okay, Kuldeep ji.
इस कार्यक्रम के आभार प्रदर्शन हेतु मैं हमारे कार्यक्रम के समन्वयक मेरे साथी विकास कुमार सर को मैं विनती करता हूं कि वे इस कार्यक्रम का आभार प्रदर्शन करें.
No, vote of thanks will be given by Manisha Yadu.
Oh, sorry sir. मैं मनीषा मैडम को रिक्वेस्ट करता हूं कि वे इस कार्यक्रम का आभार प्रदर्शन कर कार्यक्रम की समाप्ति की घोषणा करें.
Manisha, 1 minute.
Yes, ma'am.
Ghanshyam sir, on the behalf of participants, I felt it was to the point and very clear, very clear. Thank you very much for your PPT and your understanding and deliberation. Thank you very much, sir.
Thank you so much, ma'am.
Okay, Manisha ji.
हाँ जी विकास सर. सर मैं आज के इस लेक्चर व्याख्यान में जुड़े आदरणीय साहू सर का बहुत बहुत धन्यवाद देती हूँ. सर आपने बहुत अच्छा इन्फॉर्मेशन दिया है सर, क्योंकि मैं खुद अभी मेरा एनालिसिस का समय चल रहा है सर, तो मैं इस चीज को सोचते रहती हूँ कि मैं कैसे जो है अपना इसको डेटा को फीड करूं, कैसे मैं उसका रिजल्ट लाऊं. तो सर ये मेरे लिए और हम सभी के लिए बहुत ही ज्यादा सर हेल्पफुल रहेगा सर, इसलिए आपका बहुत बहुत धन्यवाद. और सभी शोधार्थी श्रोतागण को बहुत बहुत बधाई एवं धन्यवाद देना चाहती हूँ, जिनकी उपस्थिति से आज का यह व्याख्यान सफल हो पाया है। साथ ही मैं इस अति महत्वपूर्ण व्याख्यान श्रृंखला को आयोजित करने के लिए आयोजन समिति के सभी सदस्यों को भी बधाई एवं धन्यवाद देना चाहती हूँ। बहुत बहुत धन्यवाद कुलदीप सर और विकास सर और सर साहू सर जी, आपको बहुत बहुत धन्यवाद। विकास सर।
ओके, थैंक यू।
ओके, थैंक यू।
तो साहू
कार्यक्रम की
सर,
समाप्त करते हुए विकास सर औपचारिकता करें।